Red phosphorus is commonly used on matched striker pads, and it's pretty much the only source of elemental phosphorus for the average person. Although it's a readily available source, there's really not much phosphorus on each striker pad, and to get a decent amount, it takes a lot of time. I think it's only worth it if the red phosphorus is needed in small amounts for some catalytic uses or for some small scale experiments. To carry out a larger scale experiment, it would take a very long time and a lot of dedication to get enough red phosphorus. Just as an example, I used 50 grams of red phosphorus in my methyl iodide video, and to get it from striker pads, I would have had to strip something like 1600 boxes. Anyway, with that being said, red phosphorus is a useful reagent in organic chemistry. In the past, I've used it to make things like methyl iodide, and in the future, I plan to convert it to white phosphorus. White phosphorus is more reactive, and it's capable of doing some different reactions. Once I make the white phosphorus, I will use it to make something called phosphorus pentachloride, which I will in turn use to make glow sticks. For this video, I'm going to be stripping 8 matchboxes that have striker pads on both sides. I think it's important to point out that what I do here works well for these matchboxes, but it might not work well for another brand. After trying out a few different methods and solvents, I found that the easiest way was to just dab the matchbox with a wet paper towel and then scrape off the red phosphorus using a spatula. Timing with this method is important because if we don't wait long enough, the red phosphorus won't come off, but if we wait too long, it will get the box soggy. If the box is soggy, the red phosphorus doesn't scrape off very well, and we'll also get a little bit of cardboard along with it. Now I fast forward something like 10 or 15 minutes, and this is the result of scraping all 8 boxes. The next thing that I do is spray in a little bit of acetone to wash away any glue or water. When I was satisfied with the washing, I turned the bowl on the side and I poured off the acetone. At the bottom of the bowl, we're left with the red phosphorus that's wet with acetone, and to dry things off, I scraped it onto a piece of paper. Initially, the red phosphorus is pretty clumped up, but it should become much more powdery as the acetone evaporates. When I came back a few hours later, I was left with some nice powdered red phosphorus. I transferred the red phosphorus to a small piece of paper to weigh it, and the total mass came out to be about 0.24 grams. If we divide this out over 8 boxes, this means that each matchbox had about 0.03 grams of red phosphorus in total. This recovery is actually not that terrible, and I can see it as a viable method to getting red phosphorus for some small-scale experiments. Anyway, as I said before, I do plan to make white phosphorus out of red phosphorus, but I'm not exactly sure when I'll get around to it. For now, that's all I have to say. I hope you guys enjoyed the video, and I'll see you on the next one.